This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at increasing and decreasing functions and the first derivative test. Now, these are based upon a simple idea. If you have your graph going up like this, if I were to look at the tangent lines at particular points, look at this tangent line, I look at this tangent line, this one, my slope is positive. It's increasing. If I reach up here, then my slope becomes 0. It's a horizontal tangent line. Then over on this side, my tangent line's slope is negative. It's decreasing. So if your slope of the tangent line is positive, it's increasing. If it equals 0, that means you've possibly reached a relative min, relative max. And over on this side, if your slope is negative, that means it's decreasing. So that'll be the idea behind these problems. Let's take a look at our first problem here. Got f of x is equal to 12x minus x to the third. The instructions are identify the open intervals in which the function is increasing or decreasing. And this will be find intervals of increasing / decreasing. So find intervals of increasing and decreasing. Our first step is to find our derivative. So derivative of this, f prime, 12x just gives us 12. Remember, if you got a number with an x, you just drop the x. Minus x to the third. Take your power, put it out in front, lower it by 1. And that's our derivative. Step 2. Set equal to 0. And solve. We're going to see that we're also wanting where it's undefined, which we'll see that when we have a fraction. Now what this is going to give us is our critical numbers. Now critical number, critical point, critical number is basically where something's potentially happening. And for here it'll be where it changes from increasing to decreasing, or vice versa. Potentially changes, I should say. So I set the 12 minus 3x squared equal to 0. I'll take the negative 3x squared to the right side, it becomes a positive 3x squared. Divide both sides by 3. Divided by 3 is 4, and those 3's cancel and gives us x squared. Square root property says you drop your squared and you put a plus or minus square root on the other side. And square root of 4 is 2, so that gives us x is equal to plus or minus 2. So those are critical numbers. Step 3. Using the critical numbers, build a table of intervals pick test cases, plug them into your derivative, and determine your answer. Of course, for this problem, we're asking for the increasing and decreasing. Okay. I'll probably come down here and so I have a little bit of room to work. So our smallest is -2. Clue over here is -infinity. Here's x is equal to 2. And then clue over here is positive infinity. Now, this again, that separates them into intervals. So this first interval is from -infinity to -2. The second one is from -2 to 2, and then our last one is from 2 to infinity. That's our build-up table of intervals. And then it says pick test cases. You want to pick some kind of value between -infinity and -2. It doesn't matter what you pick. I'll pick -3. Here we want to choose something between -2 and 2, like 0. 0 is almost a perfect one to pick if you can. Something greater than 2, like 3, 4. It doesn't matter what you pick. Whatever value you pick will actually work. Some will be easier than others calculation-wise, though. Now we want to plug those into our second derivative, or plug them into your derivative. Plug them in your derivative. Now our derivative was a 12 minus 3x squared. So 12 minus 3x squared is our derivative. This is probably the only one I'll actually do by hand, and then I'll use the calculator to do the majority of this. Well, put the -3 in for the x, and we get -3 squared is 9 times -3 is -27. So we got 12 minus 27. Excuse me, which gives us -15. For this one, 12 minus 3 times 0 squared. 0 squared is 0 times 3 is 0, so that gives us 12. And for this one, plug the 3 in. And 3 squared is 9 times 3 is 27, so we've got 12 minus 27 again, which gives us -15. Now all we really care about these is the sign. And after you plug in your test case, if it's negative, then that means it's decreasing. If it's positive, that means it's increasing. Well, my first interval here, I came up with -15, so that means this is decreasing. Now this one is positive, so that means it's increasing. And this one's negative, so that means it's decreasing. So for our answer for this problem, it's decreasing from -infinity to -2. Then it's increasing from -2 to 2. And then it's decreasing from 2 to positive infinity. And those would be your answers. Let me save that page. Increasing, decreasing. Increasing, decreasing. Functions. And first derivative test. Page 01.pdf. Okay, let's look at our second problem here. f of x is equal to 2x to the third minus 3x squared minus 72x plus 2. Same instructions, determine where it's increasing, decreasing. So step 1, find our derivative. Take our power, put it out in front, lower it by 1. Minus 3, take our power, put it out in front, lower it by 1. Minus 72x just becomes 72, and then the derivative of 2 is 0, so that drops away. So that gives us 6x squared minus 6x minus 72. Step 2, set this equal to 0. So I got 6x squared minus 6x minus 72 equal to 0. And then we want to solve this. Well, first thing I notice is they got a GCF. They all have a 6 in common. So I factor out a 6, and that gives me x squared minus x minus 12 equal to 0. And then I'll factor using the PSD method. This factors as x minus 4 times x plus 3. Now, zero factor property. Get 0 one side, you factor the other side, you set each factor equal to 0. Now, it doesn't do us any good to set 6 equal to 0 because there's no variable to solve for there. So we'll set the x minus 4 equal to 0, and we'll set the x plus 3 equal to 0. So that gives us x equals 4, and x is equal to negative 3. Step 3. Let's see, negative 3 is our smallest one. And over here is negative infinity. And our next one is x is equal to 4. And then over here it will be positive infinity. Now we want to pick test cases. So I want to choose something between negative infinity and negative 3, like negative 4. Something between negative 3 and 4, like 0. And something greater than 4, like 5 or 6 or something like that. Doesn't matter what you pick. Now we want to plug that into our derivative, which is right here. And that wouldn't be that hard calculation-wise to do, but let's look at our calculator how to do that. Make our life a lot easier. Should have had that up and running. Well, first off, we want to go into the table set. This is only if you have a TI-3 or TI-4. So I do second window to go into table settings. And down here where it says independent, you should have ASK highlighted. If you don't, then down arrow to that line, right arrow, and put your flashing cursor on the ASK, and press enter one time. And then second mode, exit out. Now you should only have to set that one time. Let's go to y equals, and press clear. And we're going to put in our derivative, which is 6x squared minus 6x minus 72. Now we want to go over to the table. So if I do second graph, it'll go into table mode. Now you may or may not have numbers here. If you do have numbers there, go ahead and press delete to kind of clean them out. Now if it won't let you delete them, that means you didn't set your independent under the table settings correctly. And we're going to plug in our test cases. So put in negative 4, 0, and 5. Now our first number was 48, which is positive, which is increasing. And next one is negative 72, which is decreasing. And then our last one is 48, which is positive, so it's increasing. So our answer here is going to be increasing from negative infinity to negative 3. And then it's decreasing from negative 3 to 4. And then it's increasing from 4 to infinity. And those are our answers. Makes it so nice if you use the table feature of the calculator to do that basic math. Okay, let's look at this one. Got f of x is equal to x plus 3 over x minus 1. Different ways you can do this one. This is x plus 3 over x minus 1 to the first power. You can always put a first power on something. Now, all this I could take and put it up on top. And then this becomes x plus 3 times x minus 1 to the negative 1 power. Anytime you take anything opposite of where it's at in a fraction, the sign of the exponent changes. Or you could have used quotient rule. That's up to you. So let's take derivative now. So the derivative of x is 1. Now plus 3, take our power, put it out in front. Now here we got parentheses to a power. This is a chain rule, specifically a general power rule. So take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. Then you multiply it times the derivative of what's inside the parentheses. So 3 times negative 1 is negative 3. X minus 1, negative 1, negative 1, negative 2. And derivative of x minus 1 is 1, so it drops away. So this becomes 1 minus 3 over x minus 1 squared. Now, we want to get a single fraction here. Hopefully I got enough room to finish this problem. I thought about that when I started. And so I can rewrite the first fraction here, or the first part here, as 1 over 1. If you're going to get a common denominator, they both should be fractions. And since this one has a denominator 1, then the common denominator would be x minus 1 squared. Second fraction already has that. Whatever you multiply by the bottom part, you multiply by the top. So this becomes x minus 1 squared. Now that they have the same denominator, I can merge together the top parts. So I got x minus 1 squared minus 3 over x minus 1 squared. And that's our derivative. Let me double check all that. Okay, 1 minus 3 x minus... Yep. Step 2. Set your top part equal to 0. So we'll set x minus 1 squared minus 3 equal to 0. And also, you'll set your denominator equal to 0. So that's included in that. Whenever you have a fraction, you not only set top part equal to 0, but you set the bottom part equal to 0. Now in this one, I'll take the negative 3 to the right side, becomes a positive 3. Square root property, if you got something squared equal to the other side, you drop your squared, and you put a plus or minus square root around the other side. Take the negative 1 over, and we get a positive 1. So we've got 1 plus or minus square root of 3. Now in this one, whenever you have a parentheses to a power equal to 0, you can also have a number out in front. Basically, if you got that parentheses to a power, you just set what's inside the parentheses equal to 0. So we got x minus 1 equal to 0, or x is equal to 1. So now we're ready to do step 3. Build our table of intervals. Now I'm not quite sure what this is equal to. But let's come over here. I know my smallest one is going to be x is equal to 1 minus square root of 3. Click over here is negative infinity. And x is equal to 1 would be right here. And x is equal to 1 plus square root of 3 is right there. And then positive infinity is clear over here. Now, I don't know what this is exactly. 1 minus square root of 3. Square root of 3, well, square root of 4 is 2, so I know this is less than 2. So 1 minus, let's say 2 is negative 1. Well, choose negative 5. Just as long as it's clear out there, you're fine. Over here, if I think this is roughly 2, that's 3, so let's say 5 or 6. Now here, this is 1. So 1 minus this gives me a negative, so 0 would be a good one. And I need something between 1 and 1 plus square root of 3. Now I could plug in 1 plus square root of 3 to see what the exact decimal is, but I'm pretty sure that 1.01 is in this range. Again, I'm trying to emphasize here, it does not matter what values you choose, just as long as it's between these two numbers. Okay, now we want to plug them into our derivative. Now, as you've seen from the first two examples, all we care about is the sign. If it's positive, then it's increasing. If it's negative, it's decreasing. So if we look at this this part right here, x minus 1 squared. Whenever you square something, it's always positive. So our denominator will be positive in all these. Now, when part of it's positive, you don't need to worry about that part because it never changes anything. But let's look at the top part. X minus 1 squared minus 3. Well, I can plug this in my calculator if I want, or I could equally just do the numbers. You know, this one's fairly simple. If I put negative 5 here, negative 5 minus 1 is negative 6. Negative 6 squared is 36. Minus 3 is positive. Positive over positive is positive, so it's increasing. If I put 0 in there, 0 minus 1 is negative 1. Negative 1 squared is 1. 1 minus 3 is negative. Negative divided by positive is negative, so it's decreasing. 1.01. That may not be so easy, but we'll see. 1.01 minus 1 is 0.01. 0.01 squared, I don't know what it is, but it's a real small number. Minus 3 is negative. Divided by positive, so this is negative. And 5. If I put 5 in there, 5 minus 1 is 4. 4 squared is 16. 16 minus 3 is positive. Positive divided by positive. Positive, so it's increasing. It's kind of weird that came out that way. I hate decimals, so let me think if I screwed that up. 1.01 minus 1 is 0.01. 0.01 squared is 0.0001 minus 3. Yeah, that's negative. Okay. So our answer then, it would be increasing from negative infinity to 1 minus square root of 3. And then it's decreasing from 1 minus square root of 3 to 1. And then it's decreasing from 1 to 1 plus square root of 3. And then it's increasing from 1 plus square root of 3 to infinity. Now you may look at that and say, well, you said x equals 1 is a critical number, but it didn't change. It decreased here and decreased here. It may not necessarily change. A critical number just says it's potentially where something happens. Actually, our graph doesn't exist at 1. If we look back at our original problem, the domain of it, x cannot equal to 1. So it does have some kind of meaning there because it's neither increasing or decreasing. It doesn't exist. But it's where it potentially changes. Let me save that. Yeah, let's look at our next problem. Same instructions, find out where it's increasing, decreasing. Specifically, we're looking between 0 and 2 pi. So we've got f of x is equal to sine of x over 2. First step, find our derivative. This is a chain rule. The derivative of sine is cosine, and then whatever is there stays. Then we'd have to multiply it times the derivative of what follows our sine. The reason why we have to do this is because it's more than a single x. Well, derivative of x over 2 is 1/2. So we've got 1/2 cosine of x over 2. Step 2. Set this equal to 0 and solve. So we've got 1/2 cosine x over 2 is equal to 0. We could multiply both sides by 2 to get rid of that fraction. Those cancel and gives us cosine of x over 2 is equal to 0. Well, we want to look on our unicircle where cosine is equal to 0. Well, as I start going around my unicircle, here at pi over 2, we got the point 0, 1. And down here at 3 pi over 2, we have 0 and negative 1. So first place where cosine is equal to 0 at is pi over 2. The next place where it's equal to 0 is 3 pi over 2. Not that we need it, but if I take pi over 2, this right here, and if I add 2 pi, I'm back to where I started. So I'm back at the pi over 2. So also, at pi over 2, we can add 2 pi. That's also equal to 0. Now, we can also, we don't need it for this problem, but we can also take the 3 pi over 2, and we can add 2 pi, and we're back to where we started. So we can add 2 pi there. Now, we'll see why I say we don't need that. And you're saying, well, wait a minute, that goes beyond 2 pi, and you said we're looking from 0 to 2 pi. You'll find that sometimes you'll have to do this adding 2 pi over and over to get all of your answers. Now, I took pi over 2 and I added 2 pi. My next one would be take pi over 2 and add 4 pi. Okay. The only time you have to do this is when you got more than a single x here. So we're going to take this x over 2, and we're going to set it equal to the pi over 2. So we got x over 2 is equal to pi over 2. Now I can multiply both sides by 2. And we get x is equal to pi. That's our first critical number. Now we're also going to take this x over 2 and set it equal to 3 pi over 2. So I got x over 2 is equal to 3 pi over 2. Multiply both sides by 2 again, and I get x is equal to 3 pi. Now you notice this has actually gone past 2 pi. Once we go past 2 pi, then we don't need to continue anymore with these. So our only critical number is pi. Even though the original 3 pi over 2 fell within our restriction between 0 and 2 pi, once we did this little trick, it went past it. When you have x over 2, this right here, the 1/2 there, 1/2 x, means you'll have one answer. Now if you had a 2x here instead of x over 2, you'd have 4 answers. So you would need all 4 of these. If you had a 3x here, you'd need 6 answers. If you got pi over, or x over 4, x over 6, I have no clue. You might have 1 answer, you might have 0 answers. We actually like it in fraction form like this. It limits your number of answers. Okay, so we got one critical number. So here in the middle we got our x is equal to pi. Now this doesn't go to negative infinity because it says between 0 and 2 pi. So that's going to be our beginning and ending here, 0 and 2 pi. Now we want to choose something between 0 and pi. Pi over 2. We want to choose something greater than pi and less than 2 pi, like 3 pi over 2. And we want to plug those into our derivative. Now our derivative, remember, was right up here. So we've got 1/2 cosine of x over 2. So 1/2 cosine of x over 2. And just plug it in here too. Now, I'm going to put these in my calculator, even though this one comes out pretty easy. When you put pi over 2 in here, you get pi over 4, and cosine of pi over 4 is positive, so this is increasing. And if you put 3 pi over 2 in for the x, you get 3 pi over 4. And cosine of 3 pi over 4 is negative square root of 2 over 2, so it's negative, so it's decreasing. But let me show this on the calculator. First thing I want to check is make sure I'm in radians. So I press mode. And you should see radians chose, and I don't have radians chose, so I'll down arrow to that line, press enter on radians, and you should see the highlighting change to that. I'll press y equals, press clear, and we're plugging in 1/2, so 1 divided by 2 cosine of x over 2. So x divided by 2. You can put a closing parentheses at the very end if you want. TA3, TA4 doesn't need it at the very end. So now do second graph. You should have your old numbers there. You can press delete over and over to clean those out. And the first one we're plugging in is pi over 2. So I'll do second caret for the pi, divided by 2, enter. And the other one is 3 pi over 2. So I'll do 3 second caret, divide by 2. And our first one we see is positive, so it's increasing, and our next one is negative, so it's decreasing. So our answer here is going to be increasing from 0 to pi, and then it'll be decreasing from pi to 2 pi. And those are our answers. Save that. Let's look at the next problem. Grab a drink here. Got f of x is equal to 5 minus sine x. Same instructions. Find out where it's increasing, decreasing. Between 0 and 2 pi. Our first step is to find our derivative. Well, 5 drops away, minus, and then derivative of sine x is cosine x. Now we don't need to worry about chain rule because we just have a single x here. Step 2, set this equal to 0 and solve. So we've got negative cosine x is equal to 0. I can divide both sides by -1 or multiply both sides by -1, and that negative disappears. So we've got cosine is equal to 0. Now this one we can look up directly on our unit circle. Remember, pi over 2 is 0, 1, and 3 pi over 2 is 0, -1. And cosine is the x part. So our two critical numbers are pi over 2 and 3 pi over 2. Okay. So we got pi over 2. Over here is going to be 0. Then we got 3 pi over 2. And over here we got 2 pi. Now we want to pick test cases. Something between 0 and pi over 2, like pi over 4. Something between pi over 2 and 3 pi over 2, like pi. And something greater than 3 pi over 2, like 7 pi over 4, but less than 2 pi. Now I'm going to plug these in my derivative. Now again, these are pretty simple to plug in, but I'm going to do it on the calculator. We know the pi over 4 marks or the square root of 2 over 2. It just depends which quadrant you're in. Like this first one here, if I put pi over 4 in here, cosine of pi over 4 is square root of 2 over 2 with a negative out in front, gives me negative, so this is decreasing. If I put pi in here, cosine of pi, that's over here. Cosine of pi is negative 1, and negative in front of it becomes positive, so it's increasing. And 7 pi over 4, if I put 7 pi over 4 here, cosine of 7 pi over 4 is square root of 2 over 2 with a negative out in front is positive. Yeah, positive, so it's... let me think about that. Negative. Better go back to bed. Didn't sound right when I said it. Cosine of 7 pi over 4 is square root of 2 over 2, which is positive, and negative out in front makes it negative, so it's decreasing. But let's look at this on the calculator. If I press y equals, clear, and I do negative cosine x, and then I'll go to my table, so do second graph, press delete a couple times. We want pi over 4, so do second caret, divide by 4, enter. And you see it's negative, so it's decreasing. Now if I put pi in, do second caret, that's a positive 1, so it's increasing. And if I put 7 pi over 4 in, so 7 and then second caret, divide by 4, it's negative, so it's decreasing. Okay, so our answers then, it's decreasing from 0 to pi over 2, then it's increasing from pi over 2 to 3 pi over 2, and then it's decreasing from 3 pi over 2 to 2 pi. And those are our answers. Save that. And let's look at our next problem. F of x is equal to cosine squared of 1/2 x minus 1. Same instructions, between 0 and 2 pi, find where it's increasing, decreasing. So, step 1, need to find our derivative. Well, first off, let's note that this is the same as cosine of 1/2 x minus 1, all of it to the second power. That's what that squared means. Well, we have parentheses or brackets to a power. This is a chain rule. Chain rule says take your power, put it out in front. Now what's inside the brackets remains as is. That doesn't change. Lower our power by 1, so this becomes 1. And then we multiply it times the derivative of what's inside the parentheses, which is the 1/2 x minus 1. So we got 2 times cosine of 1/2 x minus 1 times the derivative of 1/2 x minus 1 is 1/2. So 2 times 1/2 gives us, well, cancels. So that gives us cosine of 1/2 x minus 1. Step 2, set that equal to 0 and solve. Now you notice we have more than a single x in here again. Well, this is where we have to go through and do that little trick. So we're going to have cosine of something is equal to 0. And I won't write it down again. Pi over 2 is equal to 0 on our unit circle. And then we want cosine of something is equal to 0, which is 3 pi over 2. Now I would keep going. I don't know how many I have to go actually. But I'd take my original answer, the pi over 2, and I would add 2 pi here. My next one, I would take the 3 pi over 2 and add 2 pi. If I needed a couple more answers, I'd go take my original pi over 2 and add 4 pi. And I'd take 3 pi over 2 and add 4 pi. Based upon this 1/2 being here, I'm guessing that we'll either have 0 answers or 1 answer, or maybe 2. I don't think we'll have more than 4. Again, what we do is you take what's inside the parentheses here, and you set it equal to what you said right here. So we got 1/2 x minus 1 is equal to pi over 2. Now I want to solve this. Whenever you solve an eighth, and if you got a fraction, you multiply everything by the LCM of all your denominators. So I'll multiply everything by 2. And those cancel and gives us x minus 2 is equal to pi. Take negative 2 over, and we get x is equal to pi plus 2. Now pi is 3, roughly 3. That's 3 plus 2 is 5. So we're fine with this answer. It hasn't gone past 2 pi. 2 pi is roughly 6. Okay, so let's do the next one. Got 1/2 x, and we'll set it equal to 3 pi over 2. So I got 1/2 x minus 1 is equal to 3 pi over 2. Multiply everything by 2 again. So 2 times 1/2 x, and 2 times negative 1, and 2 times 3 pi over 2. So that gives us x minus 2 is equal to 3 pi. I'll take negative 2 over, and I get 3 pi plus 2. Now pi is roughly 3. So 3 times 3 is 9, plus 2 is 11. That's way past 2 pi. So cross that out. And obviously we don't need to worry about these, because these would be beyond this one that we just crossed off. So we got one critical number. I actually thought we'd have 0. So I was in for a surprise. Okay, so we're going to have pi plus 2. I should quit drinking before I do these. Actually, I don't drink. This is 0. I don't think I ever did. When I did drink, I don't think I ever did at 9:29 in the morning either. That's 2 pi. So I want to choose something between 0 and pi plus 2. Well, pi would be a good one. Pi plus 2. I'm not sure if that's which side that is on terms of the 3 pi over 2. So let me just choose something here. Instead of 2 pi, this is 2 times 3.14, which is 6.28. So 6 is a little bit less than 2 pi. So I'll go with 6. Now again, we're just going to plug this into our derivative. So it doesn't have to be like something you have to look up in the unicircle if you're going to use your calculator. Coming up here, looking for our derivative. Remember, our derivative was this right here. So let's plug that in. So that's y equals clear cosine of 1/2 x minus 1. And let's go to tables. So we'll do second graph and delete those, clean them out. And our critical numbers are pi and 6. So we'll do second caret. That's positive, and then 6 is negative. So this is increasing, and 6 is negative, so it's decreasing. Remember, what we come up with is positive after we plug it into our derivative. If it's increasing, if it's negative, it's decreasing. So our answers here. It's increasing from 0 to pi plus 2, and then it's decreasing from pi plus 2 to 2 pi. And those are our answers. Save that. And let's look at the next type. Now notice it says to find the critical numbers, find open intervals which function is increasing, decreasing, locate all relative extrema. We're trying to find our mins and maxes. Relative min, relative max. What this is saying is what we indicated earlier. If we have a graph that looks like this, we're trying to find this point right here. This is going to be a relative max. And this one down here would be a relative min, if this were our graph. Now, relative max is a high point relative to what's around it. Now, it's not the highest point. You can see over here we can definitely find some points higher. It's just relative to what's around it. And it's where it changes from increasing, decreasing. Down here, our relative min, it's a low point relative to what's around it. It doesn't necessarily mean it's our lowest point of our graph, just relative to what's around it. And specifically, it's where it changes from decreasing to increasing. So that's what we're looking for. Okay, so we got, f of x is equal to x to the third minus 9x squared plus 2. And we're finding relative extrema. Our first step, find the derivative. So for a derivative for this one, take our power, put it out in front, lower it by 1, minus 9 times, take your power, put it out in front, lower it by 1, then 2 drops away. So that gives us 3x squared minus 18x. Step 2. Set equal to 0. Set this equal to 0. So set it equal to 0 and solve. Again, this is going to give us our critical numbers, just like before. I kind of give you too much in the instructions. They tell you to find the critical numbers, find increasing, decreasing, locate all relative extrema. In order to find the extrema, you have to find all those other pieces anyway. So we'll set the 3x squared minus 18x equal to 0. And first thing I'll do is factor out GCF. They both have a 3x in common, and that gives me x minus 6. Zero factor property, you get 0 one side, you factor the other side, you set each factor equal to 0. So set 3x equal to 0 and x minus 6 equal to 0. This first one, divide both sides by 3 and we get x equals 0. Here, take negative 6 over, it gives us a positive 6. And again, those are our critical numbers. In step 3, using your critical numbers, build a table of intervals pick test cases, plug into your derivative, and determine increasing / decreasing. And find your relative min / maxes. So it's kind of a continuation of what we were doing. Okay, so we got x is equal to 0. Way over here is negative infinity. Here we got x is equal to 6. And then over here will be positive infinity. We want to choose test cases, something between negative infinity and 0, like negative 1. Something between 0 and 6, like 1. And something greater than 6, like 7. Now we want to plug those into our derivative, and I'll do this one by hand, and then I'll start using the table feature. Here's our derivative, 3x squared minus 18x. Now also our derivative is down here factored, the 3x times x minus 6. You're going to find if you're doing these completely by hand, not using the table feature of your calculator, that if you go with a factored form, before you start getting rid of anything, just a factored form, that's going to be easier to figure out what your sign is. So that's what I'll plug it in. Now if I plug in negative 1, so I got 3 times negative 1, that's negative. And here I got negative 1 minus 6, that's negative. Negative times a negative is positive, which means this is increasing. Now if I put 1 in here, 3 times 1 is positive. If I put 1 in here, 1 minus 6 is negative. We get a positive times a negative, so this is negative, so this is decreasing. And if I put 7 in, 3 times 7 is positive. 7 minus 6 is positive. Positive times positive is positive, so this is increasing. Again, we could care less what the actual value is. We're just trying to figure out what our sign is so we can determine increasing and decreasing. Now, I'm going to put a note on this. Assuming the graph exists at that point, our relative max is where it changes from increasing to decreasing. And our relative min is where it changes from decreasing to increasing. So if I look at here my graph here, it's increasing and then changes to decreasing. So this right here is going to be a relative max. Then my graph is decreasing, changes to increasing. So right here is going to be a relative min. Now let me write down my increasing and decreasing, and then we'll look at our last step. So this is increasing from negative infinity to 0. Then it's decreasing from 0 to 6. And then it's increasing from 6 to infinity. It was asking for our critical numbers, which is right here. It was also asking for increasing and decreasing, which is right there. Now this, I should have said my original problem was a nice polynomial, so it exists everywhere. So I didn't need to worry about whether they exist at that point. So step 4. Plug the x values for your relative min / max into the original function to find the y values. Because they're asking for a point. Well, we said we have a relative max at 0. So let me write that down. So relative max at x is equal to 0. And we said we have a relative min, if I go straight up here, at x equals 6. So we want to plug those into our original function, which is this. Because remember, f of x is the same as y. So x to the third minus 9x squared plus 2. I'll plug that in here too. So we've got y is equal to 0 to the third minus 9 times 0 squared plus 2, which gives us y is equal to 2. So our relative max is going to occur at 0, 2. Now for our relative min, we put 6 in. We got 6 to the third minus 9 times 6 squared plus 2. Where's my calculator? Don't see it. Okay, I'll just use the one here. So I got 6 to the third minus 9 times 6 squared, which is 36, plus 2. Negative 106. Assuming I typed it in the calculator right. So I'll have relative min at 6, negative 106. And those are our answers. Let me save that. And let's look at our next problem. So we've got f of x is equal to x to the 2/3 minus 2. And same instructions. Actually, I think all the rest of the problems are the same instructions. Yeah, it looks like it. Okay. First step. Find our derivative. Well, we got x to a power. Take a power, put it out in front, lower it by 1. And derivative of negative 2 just drops away. So that gives us 2/3. X 2/3 minus 1 gives us negative 1/3. We'll take that x to negative 1/3 and take it down to the denominator. It becomes x to the positive 1/3. Okay, step 2. Set your top part equal to 0, set your bottom part equal to 0. Now it doesn't do us any good to set the 2 equal to 0, because there's no variable to solve for there. So we'll just set the denominator equal to 0. So set 3x to the 1/3 equal to 0. We could divide both sides by 3, but anytime you have a number, you get x to a power, you can just set the x equal to 0, like that. So that's our critical number. Clear over here is negative infinity. Clear over here is positive infinity. I want to choose test cases. Choose something between negative infinity and 0, like negative 1. Choose something greater than 0, like 1. Now I want to plug those into my first derivative. So 3x to the 1/3. Now if I put these in, the x to the 1/3 is like the cube root. So this would be 2 over 3 and then the cube root of x. If I put negative 1 in for the cube root of negative 1 is negative 1. Times 3 is negative. Positive divided by negative is negative, so this is decreasing. If I put 1 in here, 1 to any power, of course, is 1. Times 3 is positive. This is positive, so that gives me positive, so this is increasing. Now you could also plug those in your calculator to check that. And I do want to plug this in just to show it. Our derivative is this right here. So let's see how to enter that. If I press y equals, press clear, 2 divided by. Anytime you have more than a single variable, a single number, on top or bottom of your fraction, you have to put parentheses around it. So put parentheses around the bottom. And 3x caret. Now, if you have more than a single number or a single variable in your exponent, you have to put parentheses around it. So put beginning parentheses, 1 divided by 3. Closing parentheses on exponent, closing parentheses on denominator. Now if I do second graph, go in table. I got negative 1 and 1. So I do negative 1 inner, 1 inner. And you see I got a negative and I got a positive. So I get the same results. Sometimes it's a little tricky to put into your calculator. Even though the table method saves us work, may cause you more headaches with the entry if you're not really comfortable with the calculator. Okay, well this is our critical number here, first thing they were asking for. Now this is decreasing from negative infinity to 0, and then it's increasing from 0 to positive infinity. That's the second thing they're asking for. Okay, relative min, relative max. It's decreasing and then changes to increasing. So assuming this point exists, this is going to be our relative min. And our original problem, if I were to put 0 up here, it exists, so we're fine. So that means we have a relative min at x is equal to 0. It's always based upon your critical numbers. It's never based upon your test cases. And we want to plug that back into our original function, which is this. So we've got y is equal to x to the 2/3 minus 2. Which is 0 to the 2/3 minus 2. 0 to any power drops away, so this is y is equal to negative 2. So we'll have a relative min at 0, negative 2. And that's our answer. Let me save that. And let's look at our next problem. F of x is equal to the absolute value of x plus 2 minus 3. And same instructions. Determine any relative extrema. Our first step. This one you don't use a whole lot. Hopefully I remember it correctly. Take the derivative of the absolute value of u. This is going to equal to u over the absolute value of u times u prime. Now u is going to be whatever's inside the absolute value, which in this case is the x plus 2. So when we take the derivative, we put u up on top, which you said u is x plus 2, over, and then absolute value of x plus 2 down here, then times the derivative of x plus 2 out here. Now the derivative of negative 3, that drops away. Now the derivative of x plus 2 is 1, so that drops away, and we're left with x plus 2 over the absolute value of x plus 2. Now step 2, set your top part equal to 0, set your bottom part equal to 0. And actually, since we got 0 on this side, both of these give you the same result. You get x is equal to negative 2. Well, step 3. Build our table of intervals. Over here is negative infinity. Over here is positive infinity. I want to choose something, a test case between negative infinity and negative 2, like negative 3. Something between negative 2 and infinity, like 0. I want to plug those into my derivative. Derivative is x plus 2 over a positive number. and x plus 2 over a positive number. Now again, we could care less about this bottom part because the absolute value of whatever is always positive. And all we're caring about is a sign. So we'll put negative 3 in for x. We've got negative 3 plus 2. That's a negative 1. Negative positive is negative, so this is decreasing. If I put 0 in here, 0 plus 2 is 2, which is positive. Positive divided by positive is positive, so this is increasing. Now our graph does exist here. So looks like we just found a relative min. So it's decreasing from negative infinity to negative 2. And then it's increasing from negative 2 to positive infinity. There's our critical number over here. And our graph does exist at this point. So if we plug that back into our original problem, original function, we got f of x, which is y, is equal to the absolute value of x plus 2 minus 3. Which gives us the absolute value of negative 2 plus 2 minus 3. Negative 2 plus 2 is 0. Absolute value of 0 is 0 minus 3. We get y is equal to negative 3. So we have a relative min at negative 2, negative 3. And that's our answer. Okay, let's look at the next problem. This one looks like a quotient rule problem. So I got f of x is equal to, x squared plus 1 over x plus 2. Same instructions. Yeah. So our first step, we need to find our derivative. Top part's going to be p, the bottom part will be q. We need p prime. The derivative of x squared plus 1 is 2x. We need q prime. The derivative of x plus 2 is 1. Our formula for a quotient rule is p prime q minus p q prime over q squared. So our derivative, p prime was 2x times q, which was x plus 2, minus p, which was x squared plus 1, times q prime, which is 1, all over q squared. Now, there's nothing I can factor out of the top. Again, this is considered one group, and this is considered one group, because it's multiplication. 2 times x plus 2, and x squared plus 1 times 1. So, since there's nothing I can factor out that they have in common, I'll get rid of parentheses, combine together like terms, see where it heads to. 2x times x is 2x squared. 2x times 2 is 4x. A negative out in front of your parentheses flips the sign of everything inside, so it becomes a negative x squared minus 1 over x plus 2 squared. 2x squared minus x squared gives us x squared plus 4x minus 1 over x plus 2 squared. Step 2. Set our top part equal to 0. Set our denominator equal to 0. Now x plus 2 squared equals 0. I can just take what's inside the parentheses, set it equal to 0. So I get x plus 2 is equal to 0, or x is equal to negative 2. Now the other one doesn't factor, so I have to use quadratic formula on it. A is what's before x squared, which is 1. B is what's before x, which is 4. And C is our number at the end, which is negative 1. Quadratic formula says negative b plus or minus square root of b squared minus 4ac all over 2a. So we got negative 4 plus or minus square root of 4 squared minus 4 times a times c all over 2a. Which gives us negative 4 plus or minus 4 squared is 16. Negative 4 times 1 is negative 4 times a negative 1 gives us a positive 4 over 2. Which is negative 4 plus or minus square root of 20 over 2. $20 is 2 times 5 over 2. Again, we're looking for a pair of somethings. Here's a pair of 2s, so they're going to come out as a single 2. And remember the quadratic formula. If you can divide all three of these numbers by the same number, do so. And they're all divisible by 2. So negative 4 divided by 2 is negative 2 plus or minus 2 divided by 2 is 1. Square root of 5 over 1. Which gives us negative 2 plus or minus square root of 5. And those are our other critical numbers. So negative 2 plus or minus square root of 5. Plus or minus square root of 5. And I guess our other one was negative 2. Okay, build our table of intervals. So I'm going to have negative 2 minus square root of 5 here. Here I'll have negative infinity. Here I'm going to have negative 2. Here I'm going to have negative 2 plus square root of 5. And then clear over here will be a positive infinity. Now, here's our derivative here. So that's where we'll be plugging them into. Pick test cases. Something less than this. Square root of 5. I don't know. That's 2 point something, I think. So negative 2 and negative 2 gives me negative 4. So negative 8. That definitely is over there. Something between negative 2 minus 1 square. Negative 2 minus square root of 5 and negative 2, like negative 3. Something between negative 2 and this. Well, if this is roughly 2 point something, negative 2 plus 2 is roughly 0. So x equals negative 1 would be good. And something over here, 8's definitely larger than that. We want to plug those into our derivative, but the denominator is x plus 2 squared. So the bottom part is always positive, so we could care less about the bottom part. So the only part we have to plug it into is the top part. Now it's almost just as easy to do this by hand than it is to use a calculator, because if I plug them in, negative 8 squared is 64. 4 times negative 8 is negative 32. 64 minus 32 minus 1 is positive, so this is increasing. If I put negative 3 in there, that's 9. Minus 12 minus 1, that's negative. So this is decreasing. If I put negative 1 in here, that's 1. Minus 4 minus 1, that's negative, so this is decreasing. If I put 8 in there, 64 plus 32 minus 1, I don't know what it is, but it's positive. So this is increasing. But let me show it. Again, I don't need to worry about the bottom part. I'll just plug in the top part in my calculator. So I'll go to y equals, clear. I'll do x squared plus 4x minus 1. And I'll go to my table. I'll press delete to clean those out. And I got negative 8, negative 3. Pressing enter after each one. Negative 1 and 8. Okay, so I got positive, negative, positive, negative, negative, positive. So that's right. Really wasn't any kind of doubt there, but so then this is first off, This right here changes from increasing to decreasing, so this is going to be a relative max, assuming the point exists in our original problem. This doesn't change here. This changes from decreasing to increasing here, so this will be a relative min. And both of these exist there. Now here there was no change, so this is nothing. But even if it did change, you notice over here, -2 isn't in our domain. It does. If I plug in my original function, I get -2 plus 2 of my denominator, which gives me 0. Can't have 0 in the denominator. So no matter what, that wouldn't be a max or min anyway. Okay. So let's plug these back into our original problem. So our relative max is -2, x equals -2 minus square root of 5. And our original problem, what was our original problem? Y is equal to x squared plus 1 over x plus 2. Which would give us -2 minus square root of 5 squared plus 1 over -2 minus square root of 5 plus 2. Top part here, -2 minus square root of 5 squared means -2 minus square root of 5 times -2 minus square root of 5. Plus 1. This down here, -2 plus 2 cancels, so that gives us negative square root of 5. -2 times -2 is 4. -2 times negative square root of 5 gives us a positive 2 square root of 5. Same thing here. Negative square root of 5 times negative square root of 5 is positive 5 plus 1 over negative square root of 5. So 4 plus 5 is 9, plus 1 is 10. Plus 4 square root of 5 over negative square root of 5. Multiply top and bottom by the square root of 5. And we're going to get 10 square root of 5 plus 4 square root of 5 times square root of 5 is 5. Over -5. Let me double check that. Okay, and then this and this all are divisible by 5. And I can put this in separate fractions if I don't see that, but that would give us -2 square root of 5, and these 5s would cancel, minus 4. So our relative max going to be -2 minus square root of 5 and -2 square root of 5 minus 4. Assuming I didn't make a basic math error, which sometimes I do. Okay, so now our other one, the relative min. And our relative min was -2 plus square root of 5. And we want to plug that into our original function. I'm running out of room here. So we've got y is equal to x squared plus 1 over x plus 2. I'll skip a few steps since I showed this already. If I plug that in, I'm going to get -2 plus square root of 5 squared plus 1. And down here I got -2 plus square root of 5 plus 2, which gives us 4 minus 4 square root of 5 plus 5 plus 1 over square root of 5, which 4 plus 5 is 9, plus 1 is 10, so we got 10 minus 4 square root of 5 over square root of 5. Multiply top and bottom by square root of 5, and you get 10 square root of 5 minus 20 over 5, which gives us 2 square root of 5 minus 4. Assuming no basic math error. So our relative min will be negative 2 plus square root of 5 and 2 square root of 5 minus 4. I would double check those in the calculator just to make sure that the decimal that the calculator would give me would match what I have here, but I've been drinking a little bit too much pop, so we'll run on assumption I didn't make a basic math error. I think I'd be smart enough not to keep guzzling the pop while I'm making these videos, but I seem to do it consistently, video after video. Okay, let's see how to handle a piecewise function. So we got f of x is equal to 3x minus 1, x squared minus 2x. This is when x is less than or equal to negative 1, and this one is when x is greater than negative 1. I'm not sure if I remember the formula for this next one. I'm going to have to actually look it up. I saw that and I was thinking, well, whoa, wait a minute, I'm not sure if I remember that. It's almost there. I think I know it. Okay. Anyway, we'll cross that bridge when we get there. So first thing, take our derivative. Well, how do we take the derivative of a piecewise function? We'll take the derivative of each piece. Derivative of 3x minus 1 is 3. The derivative of x squared minus 2x is 2x minus 2. And it looks like this when x is less than or equal to negative 1, and it looks like this when x is greater than negative 1. So our conditions don't change here. We just take the derivative of each piece. Now to find our critical numbers. Well, we set each piece equal to 0. So I said 3 equal to 0 and 2x minus 2 equal to 0. Now also, besides this and this, we're automatically going to have a critical number based upon where it changes. And it changes over from negative at negative 1. So automatically this is a critical number. Now 3 equals 0, that goes away. Here I'll take negative 2 over, and we get a positive 2. Divide both sides by 2, and we get x is equal to 1. So those are our critical numbers. Well, step 3. We get x is equal to negative 1. Clear over here is negative infinity. Clear over here is positive 1. And then clear over here is positive infinity. I want to choose test cases. Something between negative infinity and negative 1, like negative 2. Something between negative 1 and 1, like 0. And something greater than 1, like 2. Now, what to plug it into? Well, it changes over at negative 1. When it's less than or equal to negative 1, you plug it into this piece. When it's greater than negative 1, you plug it into this piece. So this right here is where it changes over. Well, this interval here is less than or equal to negative 1. So for this one, we'll plug it into 3. And for this one, we'll plug it into 2x minus 2. And same with this one. So again, this tells you which piece do you plug it into. Less than negative 1, you plug it into this first one, the 3. If it's greater than negative 1, you plug it into the 2x minus 2. Well, 3 is always positive, so I know this is increasing. If I put 0 here, 2 times 0 is 0, minus 2 is negative, so that's decreasing. If I put 2 here, 2 times 2 is 4, 4 minus 2 is positive, so that's increasing. Now, this is possibly a max. So I'll put a question mark there. And this one right here is a relative min. Remember, where it changes over from increasing to decreasing is relative max. When it changes over from decreasing to increasing, it's a relative min. And I say, possibly. Well, what do you mean by that? Well, if you remember our piecewise functions, you may have a piece that comes up like this, and this is where it changes over. And then it changes over to this. So here it'd have a relative max. But you can also have it come up like this, and then the other one continues over here, which means that there wouldn't be any kind of min or max here. Well, how do you determine which case it is? Take -1, plug it into to both pieces, and see if it gives you the same y value. That tells you whether the two pieces meet. Now this one's okay. Okay, so let's test that. We're wondering what's happening at -1. So we'll plug it in our first piece, the 3x minus 1. And we'll plug it in our second piece, which is the x squared minus 2x. Well, I got 3 times -1 minus 1. 3 times -1 is -3, minus 1 is -4. And if I put -1 in here, I'll have -1 squared minus 2 times -1, which is 1 plus 2, which is 3. These do not match, do they? Which means that this is not a relative max. So the only one we have to worry about is our relative min at 1. So we got relative min at x is equal to 1. Actually, let me write down my increasing and decreasing. So it's increasing from -infinity to -1. And then it's decreasing from -1 to, what was that, 1, I guess? And then it's increasing from 1 to infinity. Now, which piece do we plug that into? Come up here, x is equal to 1. You come over your conditions here, and you ask yourself, it's kind of like you plug 1 in for the x. Is 1 less than or equal to -1, or is 1 greater than -1? Well, 1 is greater than -1, so we'll plug it into our second piece. We'll plug it into x squared minus 2x. So we got 1 squared minus 2 times 1, which gives us 1 minus 2, which is -1. So we're going to have a relative min at 1, -1. And those are our answers. Let me save this. And time for my tablet to blow up, so I'm going to bring up a new copy. Excuse me. And let's take a look at this one. Let's see if I can remember how to do this. Let's see, 5 to the x squared minus 1. Okay, so if I were to take ln of y is equal to ln of 5 to the x squared minus 1, get natural log of y is equal to x squared minus 1, natural log of 5, and so then this would become 1 over y prime, and that's just a number, so that stays there. This gives us 2x times natural log of 5, multiply both sides by y, and y is equal to this, 2x, okay, now I remember the formula. Actually, I don't remember, I derived it. If we got a, which is a number, to the u power, and u can represent anything, then that's going to equal to natural log of a times a to the u times u prime. If I had a memory, it'd be great. Neat part about math is you can derive a lot of it. You derive it enough in your head, and you got it. Okay, now let's look at this problem. So we got f of x is equal to 5 to the x squared minus 1. First step, find our derivative. And from our formula here, it's going to, a is 5, and then our u is the x squared minus 1. So we're going to have the natural log of 5, and then 5 to the x squared minus 1. That doesn't change. But then you have to multiply it times the derivative of your exponent. So that's going to give us natural log of 5 to the x squared minus 1, and derivative of x squared minus 1 gives us 2x. Step 2. Set this equal to 0 and solve. Now if I set the natural log of 5 equal to 0, that's just a number, so there's no variable to solve for there, so we don't need to worry about it. So we'll set the 5 to the x squared minus 1 equal to 0, and I'll set 2x equal to 0. Well, 2x equal to 0, that gives us x equal to 0, so that's our critical number there. Now the other one is an exponential equation. And if I go through my steps for solving the exponential equation, get to part of the variable and the exponent by itself, no numbers in front of it, no numbers after it, which it is. Next step is to take natural log of both sides. So we'll take ln of both sides. But when I do that, I get natural log of 0, which we can't have, so that crosses off. Actually, whenever you have a number to some kind of power equal to 0, you never need to worry about it, because if you think about your asymptotes when we saw these in college algebra, it can never equal to 0. So our only critical number is 0. So we get x equals 0 here. Clear over here is negative infinity. Clear over here is positive infinity. Well, I choose test cases like negative 1 and positive 1. Now, natural log of 5. Let's see what in the world that's equal to. I have no clue. I think it's positive. Do second mode, natural log of 5. It's positive. So I don't need to worry about that. That's positive. Now, 5 to any power is always positive. So the only thing we have to worry about plugging into is the 2x, which makes it real easy. Now, if you don't see this, plug this in your calculator and just use your table. It'll be obvious. If I put negative 1 in here, 2 times negative 1 is negative, so it's decreasing. If I put 1 in here, 2 times 1 is positive, so it's increasing. Assuming it exists here, which it does, this is our relative min. So this is decreasing from negative infinity to 0, and then it's increasing from 0 to positive infinity. And step 4. We've got a relative min at x is equal to 0. So let's plug that into our original function. Our original function is y is equal to 5 to the x squared minus 1. So we've got y is equal to 5 to the 0 squared minus 1. 0 squared drops away, so we've got 5 to the negative 1, which is 1/5. So our relative min is at 0, 1/5. And that's our answer. Let me save that. Let's look at our next problem. Oh, I am so sore. I went to the YMCA this morning and legs are killing me, back's killing me. I'm getting old. Let's take a look at this next problem. I guess since there's no cheese, I'll quit whining. Okay. Well, this is the same instructions. This will be the quotient rule again. So this will be P, and this will be Q. Now we have something additional on here when we're dealing with natural logs, which we'll talk about here in a minute. To find our derivative, we need P prime. The derivative of a natural log of x is 1 over x. And derivative of x is 1. So we got P prime Q minus P Q prime over Q squared for a quotient rule. So for our derivative, P prime is 1 over x times Q, which was x, minus P, which is natural log of x, times Q prime, which is 1, all over Q squared, which is x squared. 1 over x times x is 1, minus natural log of x over x squared. And that's our derivative. Step 2, set your top part equal to 0. So we've got 1 minus natural log of x is equal to 0, and set your denominator equal to 0. So x squared is equal to 0. Well, this one gives us x is equal to 0. On this one, I want to get the log by itself, so I take the negative natural log of x to the right side, becomes a positive natural log of x. This is how to solve a log equation. You get everything with a log on one side, numbers on the other side. Take your base, which is e. Whenever you have natural log, it's always base e. So take your base to a power of the other side. So we got e to the first equals what follows our log. So we got x is equal to e, which is 2.7 something. And we also got x is equal to 0. So I got x is equal to 0, and x is equal to e, and then clear over here is positive infinity. Now I don't go over here because if we look at our original function, natural log of x, you can't have log of 0 and you can't have log of a negative number. So it actually, my interval starts at 0. It doesn't exist over here. So it doesn't exist. So I want to choose test cases. Something between 0 and 2.7, like 1. Something greater than 2.7, like 3. Now we want to plug those into our derivative, which is right here. Now the bottom part is x squared, so it's always positive, so I don't need to worry about it. Only part I need to plug it into is the top part. Natural log of 1. I think that's 0. But let's see, just to be on the safe side. 1 minus natural log of 0. Let's say 0. 1. Yeah, it is 0. So that's a positive, positive divided by positive, so this is increasing. If I put 3 in, 1 minus natural log of 3. Okay, that's going to give us a negative. So this is decreasing. And again, assuming it exists here, this is going to be our relative max, which it does exist there. So it's increasing from 0 to e, and then it's decreasing from e to infinity. And step 4. Our relative max is going to be x is equal to e. And we'll plug that into our original function. So we've got natural log of x over x. Which gives us natural log of e over e. Now this is base e. And remember, when your base here matches this, they cancel away and leave you the exponent, which is a first power here. So that gives us 1 over e. So our relative max is at e 1 over e. Let me save that. Hopefully you remember those rules from college algebra for logs. They really do help you in calculus. Don't help you very much in college algebra, but use them. They become very handy in this class. I see the light at the end. Of course, my mouth's getting real dry because I'm not drinking anything also. So let's see, we got x squared e to the negative x. Same instructions, I think, yeah. Let me grab a drink here. I lied, so. This would be the quotient rule. Quotient. Product rule. I better go back to bed. This will be P and this will be Q. So for our first step here, need P prime and Q prime. Derivative of x squared is 2x. For Q prime, the derivative of e to a power is e to the power times the derivative of the exponent. If you got more than a single x here, which we do. Derivative of negative x is negative 1, so that gives us negative e to the negative x. So for our derivative, P prime is 2x times Q, which is e to the negative x, plus P, which was x squared, times Q prime, which is negative e to the negative x. Well, I notice they both have an e to the negative x, so I can factor that out in front. And that leaves us 2x, this negative I can put out in front, minus x squared. Step 2. Set this equal to 0 and solve. So we got e to the negative x times 2x minus x squared equal to 0. The zero factor property says we want to factor everything, and I can factor an x out of these. So I got e to the negative x times x times 2 minus x equals 0. Now I set each factor equal to 0, so I set e to the negative x equal to 0. I'll set x equal to 0, and I'll set 2 minus x equal to 0. Now, e to the negative x equals 0. Again, this is an exponential equation. E is just a number. It's 2.7 to the negative x power, which this can never equal to 0, so we get nothing off of that. That's the same as that last problem we just did. Now, this one's x equals 0. That's already solved. Here, I'll take the negative x over, and we get x is equal to 2. Okay, so we got 0. Here's negative infinity. And here's 2. And then here's positive infinity. I want to choose test cases. Something between negative infinity and 0, like negative 1. Something between 0 and 2, like 1. Something greater than 2, like 3. Now we want to plug them into our derivative. And again, the factored form of your derivative is probably the best place to plug it into. Now here we got e to a power. Whenever you have a number to a power, even if it's a negative x, that's always positive, so we don't need to worry about that. The only part we need to plug it into is the x times 2 minus x. And again, if you don't see that, just plug it in your calculator. It'll come out that way anyway. If I put negative 1 in here, that's negative. 2 minus a negative 1 becomes 2 plus 1, which is positive. Negative times a positive is negative, so this is decreasing. If I put 1 in here, put 1 in for x, that gives me positive. 2 minus 1 is positive. Positive times positive is increasing. If I put 3 in here, that's positive. 2 minus 3 is negative. So positive times a negative is negative, so it's decreasing. And assuming it exists, this changes from increasing or decreasing to increasing, so this is a relative min. This one changes from increasing to decreasing, so this is a relative max. Let me write down increasing, decreasing. Okay, decreasing from negative infinity to 0. Then it's increasing from 0 to 2. And then it's decreasing from 2 to positive infinity. Okay, so we're going to have a relative min at x is equal to 0. And we'll have a relative max at x is equal to 2. I want to plug those into our original function, which is y is equal to x squared e to the negative x. Y is equal to x squared e to the negative x. So here we get y is equal to 0 squared times e to the negative 0. Well, 0 squared is 0. 0 times anything is 0. So our relative min will be at our origin, 0, 0. And for this one, I'll plug 2 in. So I got 2 squared e to the negative 2, which gives us 4 over e squared. So our relative max will be at 2, 4 over e squared. And those are answers. I swear my wife's calling everybody in Wichita. All I hear is call one number after another. I don't know what that means. Could be that she has a lot of friends and I have very few. Okay, let's look at this one. F of x, our last one. Of course, she'll probably be getting into the bathroom and taking her 3-hour shower she does. Okay, blah, 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 increasing, decreasing, extrema. Okay. I'm not going to do the graphing calculator to verify it, but still looking from 0 to 2 pi. So far, derivative. Square root of 3 stays out in front. Derivative of cosine is negative sine. Minus derivative of sine is cosine. So that's going to give us negative square root of 3 sine minus cosine. Step 2. Set this equal to 0 and solve. So we got negative square root of 3 sine x minus cosine x is equal to 0. Now since they're both negative, I could go ahead and just divide everything by negative, make everything positive. But I won't worry about that. I'll take the negative square root of 3 sine x to the right side. So we've got negative cosine x is equal to square root of 3 sine x. Now, we're wanting to solve this, so I'm going to go ahead and square both sides. Not saying this one comes out nice. We may have to use a calculator. We may have to use the intersect method to get this. But we'll square both sides. Now, negative, anything positive or negative when you square it's positive. So this gives us cosine squared. And square the square root of 3, and that gives us 3. And this gives us sine squared. Now, sine squared I can rewrite as 1 minus cosine squared using our trig identities. Remember that. We have sine squared plus cosine squared is equal to 1. I can solve this for sine squared. So I take cosine squared over, and sine squared is equal to 1 minus cosine squared. And that's where that came from. So then we got cosine squared is equal to, try it again. Cosine squared wasn't much better, but it's equal to 3 times 1, which is 3, and 3 times negative cosine squared, which is negative 3 cosine squared. Now, I'm going to take that negative 3 cosine squared over to the other side. So we got cosine squared plus 3 cosine squared is equal to 3. Combine these together, we get 4 cosine squared is equal to 3. Divide both sides by 4, and we got cosine squared is equal to 3/4. Now the square root property from college algebra. If you got something squared equal to the other side, you drop your squared, and you put a plus or minus square root around the other side. Now we can't have a fraction inside of a square root, so put a square root around top, square root around the bottom, which gives us square root of 3 over 2. Now here at pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. We're going around our unit circle. We're looking where cosine is equal to either a negative square root of 3 over 2 or a positive square root of 3 over 2, which is these 4 places. So we got x is equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Maybe. Now, going back to our original equation here, which is this right here. When you, first off, use identities to rewrite it, and second off, when you take both sides to a power, either one of those tells you need to check your answers. Because you get right answers, but sometimes you get false answers. So if we plug this back in, pi over 6 here. If I put pi over 6 here, sine pi over 6 is 1/2. So that gives us negative square root of 3 over 2. And if I put pi over 6 here, that gives us square root of 3 over 2. Negative there doesn't work. If I put 5 pi over 6, sine 5 pi over 6 is 1/2 times negative square root of 3 is negative square root of 3 over 2. Cosine of 5 pi over 6 is negative square root of 3 over 2, and negative gives me a positive square root of 3 over 2, so that one checks. Actually, they have to be different signs for this to actually work. So if we come down here, 7 pi over 6, that won't work. And our other one's 11 pi over 6. So those are our 2 critical numbers. And so for step 3, let's see. Here we got 5 pi over 6. Here we got 11 pi over 6. Now clear over here is 2 pi, and clear over here is 0. So that's what they're telling us to look between. Now I'm going to choose test cases. I'm going to choose something between 0 and 5 pi over 6, which would be pi over 2, I guess. Would be a good one. Something between 5 pi over 6 and 11 pi over 6. Pi would be good, I guess. And something between 11 pi over 6 and 2 pi. Pi is 3.14. This is 6.28. 6.1, I'm pretty sure, is in that interval. If we want to plug those into our derivative, where's our derivative at? I guess this is what I circled is fine right here, negative square root of 3. Let's put that in the calculator because I'm kind of lazy and I never drank too much pop too. So let's see. So we got y equals, and then clear, negative second x squared 3, closing parentheses on the radical, sine x. So sine then x, and I'll put a closing parentheses on the x, minus cosine x. Do second graph to go in table. And clear those out. And we got pi over 2, so second caret divided by 2. And then we got pi, so second caret. And then we got 6.1. So we got negative decreasing, then it's positive, so it's increasing, and then it's negative, so it's decreasing. So this changes from decreasing to increasing, so this is a relative min, assuming the point exists, which it does. This changes from increasing to decreasing, so this will be a relative max, assuming it exists, which it does. So let me write down increasing and decreasing stuff first. So it's decreasing from 0 to 5 pi over 6. And then it's increasing from 5 pi over 6 to 11 pi over 6. And then it's decreasing from 11 pi over 6 to 2 pi. Okay, so we're going to have a relative min at x is equal to 5 pi over 6. Let's plug that in the original function. So we've got y is equal to square root of 3 cosine x minus sine x. So square root of 3 times cosine of 5 pi over 6 minus sine 5 pi over 6. Now if I look these up on my unit circle, cosine of 5 pi over 6 is going to be negative square root of 3 over 2 minus, and sine 5 pi over 6 is 1/2. Well, square root of 3 times square root of 3 is 3, so that gives me a negative 3/2 minus 1/2. Gives us negative 4/2 or negative 2. Boy, that came out nice. Always makes me wonder if I screwed it up when I do that. So this is 5 pi over 6, negative 2. And relative max is 11 pi over 6. So relative max is 11 pi over 6. So again, we'll plug that into our original function, which I think that's it. Yeah. So I got square root of 3 cosine of 11 pi over 6 minus sine of 11 pi over 6. Now cosine of 11 pi over 6 is square root of 3 over 2 minus sine of 11 pi over 6 is negative 1/2. Which gives us square root of 3 times square root of 3 is 3, so that's 3/2. Minus minus is positive, so that's 1/2, which gives us 2. Which means we'll have a relative max at 11 pi over 6, 2. And those will be our answers. Let me save that. I believe that's the last problem. Yes, it is.